So we're going to fit this fixing dovetail and scope rings, and we're going to get it so it will fit onto the telescope properly and onto the mount. So first thing I want to do is get your 6mm Allen key. Again, there was no tools issued with this telescope, so again I flip it all out, unlock these, okay, and these are just M6 Allen bolts you unscrew off. As you can see here, they've used stainless steel Allen bolts with high tensile strength, so straight away they've used decent Allen bolts, okay. And this setup can just basically you can slide these scope rings back and forth to get the exact angle, okay. Alright, so what we do is you're going to put this on the telescope, you extend the tube up like so, you place your scope rings over the tube. Okay, you then clamp them down. So wind them up, clamp them down. You then get the other scope ring, same detail, put it over. Like so, and scope rings clamps down like so. So that's just a rough adjustment. So we've got the scope rings there. You then tilt the telescope round, and then you fit your dovetail. Now as you fit a dovetail, ideally you want the dovetail to be more or less sticking at the back, because don't forget, when you fit your camera on there and onto your mount, the dovetail needs to go further back, and you'll see the reasons why. So we put the screws back in there, and we're going to line them up into the holes. But this is quite a good quality dovetail anyway, and I do like how they're slots, so you can slot it back and forth, okay. Again, it makes it lightweight as well because it's slotted. But what we're going to do is we're going to have it on the fore end like so, like that. So you lock them in place, nip them up so they're tight. Alright, there you go. So that's dovetailing. You then readjust the focuser and the main tube a little bit better. So you slacken the scope rings a bit and just tilt it like so. You should have your focuser. You can still enable you to reach the lock screw on there, okay. So that's the scope rings in place properly. Again, you've got a massive amount of play here, but we'll be able to show you how to balance that. So that's that. You can remove the cap, okay, if you wish. Now this is the item, this is the shorter Vixen dovetail, and you want to be fitting that onto the top of the scope rings like so. Okay, now you can attach these using these screws, alright, using the metric 6 stainless steel screws, alright, and you can place this along the scope rings here. So then, using the metric Allen bolts, like so. We can line them up to these holes. And again, you might have to adjust the scope rings, okay, like I've just shown here. So again, you've got to tilt it back round, and we're just going to adjust these scope rings a bit more. Okay, so we slacken that out, and we're just going to slide the scope rings out. Like so, slacken them out and then push them along, okay? So we're going to slide it out like so. So we slide these scope rings out, okay? We then tilt around. And we're going to line up these two holes. And then, again, it doesn't really matter which position you want to line it up to. It really depends on your setup. And again, we've gone over. So, we'll line up one first. Okay, just enough so I can slide it up and down. We then tilt around. And then we're going to slide that back in, like so. We then line up the dovetail again, like so, and we've lined it up. And then we can then tighten up the Guidescope dovetail. Again, when you're sliding these must be loose, these scope rings. Again, we're going to tighten them up. Just nipped up, not over tighten them, just nip them up enough so they don't come free. We then tighten up the top Vixen bracket, tilt it round. We're going to then tighten up the remaining screws. Okay, so that is now your dovetail clamping system installed. We get our Vixen dovetail clamping mechanism, and this goes a certain way. It's chamfered, so it basically goes like so, like that, like so. This will clamp on here like that. However, we push this telescope from one side. We want to mount the clamp onto the Guidescope. I'll line up these two holes here. Okay. We're just going to remove the eyepiece so it's out of the way. So we grab our bigger screws. Okay, they go into these little slots here and here. You then line up on these holes here. Get your 6mm Allen key. Couple of threads, just try and get it lined up, don't try and cross thread them. So they go into these little big slots. Okay. Okay, that was tight and that was tight. Okay, they're nipped up. There should be no free play. We then grab our telescope and then we can slide in and we clamp the bottom thumb screw like so. That is now the finder guider, the clamping system in place. Okay, so we're going to measure the actual total weight with the total setup with the Guidescope and the Horizon 72 with all the Vixen dovetail clamps and all that. So we're going to measure her up carefully to find out how much it really weighs. Okay, I'm going to leave the dust caps on and I'm going to carefully okay, so that is everything. This is not including the field flattener, right? This is without it. And already we're at 3,884 grams. So that works around about just under 3.9 kilograms for the whole setup. So if I add the field flattener and the camera and my Guidescope camera, we could be looking probably around 4.5, just under 5 kilogram limit, which means that telescope setup will be suitable for the Sky Adventurer mounts or the Ioptron mount. So you can use this telescope complete setup, but bear in mind you'll be really up to the limit on those mounts. So a minimum of a Star Adventurer or an Ioptron Smart EQ mount will be able to take the weight of the complete setup with a DSLR camera. So I thought I'd highlight this. It is quite a robust setup, don't get me wrong, but if you're going to mount it on those mounts, you'll be really up to the payload on those mounts. So we're going to use the Skywatcher EQ5 mount. This is the SynScan variant of the Skywatcher series. Again, this is a very good mount. I've used it quite a few times. It's been a workhorse for my astro imaging for many years, and I've been getting some outstanding images with this astrophotography mount. Yes, it's one of the basic mounts you can buy, but I think the EQ5, despite some of its glitches that it has over the years, again, I have super tuned it. So again, if you're interested in super tuning your EQ5 mount, check out the link at the top. I highlight how to tune this mount up so that you can get the very best performance out of it. Alright, so I've super tuned it. Alright, this mount is capable of a payload of 9 kilograms. It can go up to 10 kilograms at a push, but I won't recommend it, to be honest with you, when you're using it for astrophotography. It's got a 5 kilogram counterweight in there, and all I do is at the clamps here, I'm going to line up my telescope. I'm going to line up the Horizon 72 ED imaging setup on there, and I'm going to lock it in place. Okay, I'm going to tilt it so you can see it. So here's the clamps here. I'm going to line it up all the way down. I'm going to lock it in place. That's that in place. I'm just going to lock it back in like so. So at the moment I can use the telescope using the 1.25" or 2" format nose pieces, so I can attach my DSLR camera. However, I'm going to fit the rotatable 1x field flattener, alright, and reasons for that is in the manual it's very detailed, but I like to show you how to install it. So at the moment there are 3 tiny screws at the bottom, okay, so you get 3 screws either side that are adjacent to each other at 120 degrees. So all you do is using a very small Allen key. Now I don't know what sizes they are. I've got loads of size Allen keys, but I think they're around about 2mm or 1.5mm Allen keys. And what I do is I slacken these tiny little grub screws. Okay, slacken them out one by one. There's another one at the bottom here. And this one as well. So three grub screws are slackened off. Then I'm going to unscrew the visual back, the blue visual back, like so. So the visual back unscrews like so. So as you can see here, we've got tiny little 1.5mm screws here. These are very, very tiny. And you have to unscrew each bit like so, just to make them loose. Now these screws clamp onto the tube on the ring. However, you can use a very sharp knife and just get it on the tip, but I won't recommend it because you might round the ends of these screws. So you need to use a very tiny screwdriver kit. I don't know what size they are, but I'm guessing it's probably quite small anyway. And once you slacken them off, you just slacken off the ring. If you take it out, you slacken off the ring. Right, and as you see, the ring comes off completely. These are the tiny screws I was talking about. These tiny screws are very tiny. So yeah, just be careful with them. Don't round them off. We then get our flattener with the thread here. Alright, so there's a flattener, and we're going to unscrew it into the tube. Okay, screw it in. Like so. So with our field flattener installed, we then install the thumb screw. There's a little hole located there. You just put in the thumb screw like so. What that thumb screw will do will help to clamp this field flattener so it doesn't come off and unscrew. So that's the field flattener installed. And it's quite simple, as you can see there. If you slacken that out, you slacken this thumb screw, you can rotate field flattener round and round. Very good security. There's hardly any free play at all. In fact, none at all. Alright, once you get rotated, alright, you just lock it in place, and that's the field flattener installed. Then you have a T-thread here where you attach your DSLR camera using a T-ring adapter. So we've got the field flattener installed. However, one thing I need to highlight is that this field flattener can only attach M48 camera threads. So this is like a spacer. This is a spacer already designed for a typical DSLR camera, particularly like a Canon or a Nikon camera. So something like this DSLR camera, which I have here, this is the Canon 600D. This is already a Barda filter modified camera, and it has the cooling as well, it has the Peltier cooling. Unfortunately, I've come across this. I'm using the existing T-ring adapter. I install it onto the camera. That's locked in place. So I'm going to fit the camera, and look, as you can see here, I can't install it. So I need to find a way to install this T-ring onto this field flattener. Now I know the main reason why they've used the M48, because the M48 gives you a much wider field of view, so that if you want to use full frame digital cameras, you're not going to get vignetting. So the whole idea with this, using the M48 thread, will give you a much wider field, so that your sensor on your full frame sensor on your camera is not going to crop along, and in other words, what it's going to do, it's going to cause vignetting in your images. So it's going to stop your full frame camera from getting this vignetting. Unfortunately, if you're using the APS-C sensor, which is this half crop sensor, this CMOS sensor, it's not going to fit. So be careful to check your T-ring adapter. So if you're going to fit this photocool reducer, you must have an M48 thread T adapter. Alright, the T2 is way different, it's a lot more smaller. So just something I need to highlight for you guys and girls: get an M48 camera adapter to fit onto this photo reducer. So luckily I have a Barda T-ring adapter. Now this T-ring adapter, I've highlighted it in many of my videos. Alright, if you check out the link at the top, I highlight this adapter in one of the photocool reducer and field flattener adaptation video. Now on this T-ring adapter, this has a T2 and an M48 thread in there. And we want to convert this T-ring to accept the M48 thread on the field flattener. So we use one of these tools. This is an optical lens removal tool. Again, you can buy this from Rother Valley Optics at a good price. And what we're going to do is we're going to remove this T-ring, and there's two holes here. And all we do is line it up like so, and we're going to unscrew this thread. So you keep doing it until, like so, you expose the M48 thread. We then connect it to the camera like so. That is now the camera adapter converted to an M48 thread. So we now got a camera converted to an M48 thread. However, what I found easier to install this camera onto the field flattener, we take off the T-ring adapter and we just screw onto the field flattener. Okay, that's the T-ring installed. We then get our modified Canon 600D and we're going to connect it onto the telescope that way. We've now got the camera installed onto the telescope, and I'm going to show you this unique feature. So you can rotate the camera like so to your orientation, and then once you get the right orientation, you lock the thumb screw like so, and that's the camera installed. So now we've got the whole imaging set up, camera installed, field flattener installed, everything. Because we've got a long dovetail, we need to counterbalance this mount. Okay, it's very crucial that you do that. Okay, one, it's gonna, if you counterbalance the whole system, one, it's going to help the mount bearings and shafts not going to be under a lot of stress. Plus, it will prevent your whole setup from colliding against the base of the mount and or the tripod legs, and you don't want that. So it's very crucial that you counterbalance everything. So what we're going to do is we're going to counterbalance the RE axis like so, and as you can see, we're checking side by side so that, and already as you can see here, I'm balanced quite well. Now if the counterbalance is too much, what you find is if it's down here, okay, like so, you just need to move the counterweight up. Again, once you've got it to a position, you tilt it. There should be, it should be free to rotate, but should not be tilting the walls or whatever. So you should have it balanced that way. And then once the RE axis is balanced, okay, you lock the RE axis, and now this is where it's important to do the deck axis. So we're selecting the deck axis and carefully, and as you can see, I'm way, and see I've got loads of, see I'm way top over there. So what we do, because we're way top heavy, we need to move the counterweight up or down. Okay, so we need to, so we lock the deck axis, we need to move the dovetail up and down, all right, to get the perfect balance of the deck axis. And to do that, you slacken off these screws here to slide the dovetail up and down. Also, because we're top heavy on the top, we need to slide the dovetail down. Once we get to a position, we slacken the deck axis and then we tilt the telescope, and as you can see, we are counterbalanced on the deck axis. So we're now balanced in both axes, and as you can see there, it should be smooth all the way through. So a point to note, if you're focusing with your camera, okay, if you're focusing, you may find that the draw tube may affect the balancing. So if my draw tube was up to about here, alright, and I've got the image focused, I might have to rebalance the RE axis and the deck axis. So if I got focus there, if I slacken the deck axis, you'll probably find that, as you can see here, the deck axis on the camera side is pushing it down. So I need to move the dovetail up. Once I've left it up, I then check my deck axis and I'm balanced. In fact, no, a bit too much there. And as you see, you've got to readjust the Vixen dovetail, slide it back down, and then check again. Yes, there we go. I'm balanced now. Probably need to adjust it a bit more. Slide. That's it. One slow nudge. There you go. Check again. There you go. I'm balanced on the deck axis. So, point to note, if you focus your tube, you've had to focus a lot more out. This will affect balancing on the deck axis a bit more. So you have to move this dovetail up and down so that you can get your perfect balancing. Both axes now are both balanced, and I should be ready to go. So, as you can see there, even the Guidescope, the optics are well made, and that FPL 53 ED doublet glass looks amazing on this scope. I'm going to show you the viewfinder through the so we've got that tower through the reticle. That's what it looks like through the reticle. So very sharp even through the Guidescope. However, what I need to point out is this focuser. Now this Guidescope is designed for a guide camera. This will focus to the guide camera, and even when I rotate this, alright, this stays put, alright, this does not rotate, so this will slide up and down. The only trouble is though that the eyepiece reticle, for that image to be focused, I have to loosen this screw and slide it back and forth to get focus. So if you want to use it as a finder scope, you're going to have to, this focuser tube is extended all the way out, so I had to loosen this to move this eyepiece further out more to achieve focus on that tower. So that's something to highlight if you're going to use this Guidescope as a finder scope. But apart from that, both telescopes are aligned, and as you can see there, it was very easy to set up, so it wasn't hard. You might have to adjust the adjuster screws to get the Guidescope in line with the main tube, but this is what I would do, is focus on a terrestrial object like that tower for example, get it into the optical tube of your main scope, and then use and then just the Guidescope in there in line with the main tube, and you should have perfect alignment. So I fitted a normal DSLR camera, and I've got the telescope pointing at a terrestrial target, which is a tower, and as you can see there, oh my god, I'm absolutely amazed with the optical quality there. So this is very impressive image quality there. So as you can see here, we've got that tower, and I'm recording through my camera, and as you can see there, the sharpness is unbelievable, very crisp, and there's hardly any false colouring, there's no fringing, and this is very impressive. I must admit, that field flatteners helped flatten it out as well. So here's a close-up. We adjusted the camera zoom, and as you can see there, we've got awesome contrast there, and I mean it's very sharp. And if we take a closer look, it is sharp all the way through. Now don't worry about the shimmering. The shimmering is the warm air escaping my room, so don't let that put you off. However, what we are concerned about is in this detail there, in that image, there's hardly, in fact I can't find any colour fringing. There's no colour fringing whatsoever in there. So that just shows you how good and how sharp FPL 53 glass is. So fantastic optics so far, and as you can see there, it is contrast, it's sharp, there's no colour fringing, we've got a very sharp image, it's nicely refined. In fact, to be honest with you guys and girls, I really think this could match a triplet any day. Now, I've owned triplet refractor before, and the sharpness on those telescopes are absolutely amazing. But looking at that image there through this 72 ED, this is really impressive to say the least. And I've got to be honest, I've got to hand it to Rother Valley Optics. That optical glass has really corrected that image. So, what do you reckon, guys and girls? Yeah, this is really quite an impressive instrument, to say the least. And to be honest with you, looking at that tower you've just seen there, the image quality is very sharp and crisp, very contrast, and to be honest with you, it's almost like a triplet in its way. So it just shows you that FPL 53 glass, the optical glass that Rother Valley Optics use, is quite impressive. Now, so far what I've seen, as you can see there, it's extremely easy to set up. Please use that guide, use this video as a guide to set it up. It's got some nice features, very good quality tube, a very high quality optical glass they've used. I do like the rack and pinion focuser, which is heavy duty, and I think it could handle quite easily 500 kilograms of camera and maybe a heavy duty filter wheel. But as you can see here with my Canon DSLR with its filter cooling mod, it can hack the weight quite easily. I do like the Guidescope. I do like how Rother Valley Optics have introduced this finder guider system, so you can use it as a finder or a Guidescope. And I do like how they use the helical focuser and adaptive T-ring, so you can attach a DSLR or any CCD or CMOS Astro camera. The whole setup as well, I like how they use the step ups so that you can get underneath the focuser and lock it in position. I do like how they've used a really big dovetail bar. I think, to be honest, it's a bit too extreme for this setup. However, if you're using heavier DSLR cameras or filter wheels or any other Astro cameras, then I do like how Rother Valley Optics are giving you a bigger dovetail. Now, I've not seen that on a lot of astronomy telescopes. I've not seen that in a lot of manufacturers at all that's done that. Again, they've used easy quick release clamps, and I also like how you can adapt another dovetail, so you can have like a finder scope and a Guidescope in between that. So there's some very nice touches on this telescope. I do love the case. The case is outstanding. I've never seen a case like it. And everything, the colour, it's absolutely stunning. And the best bit is, I do like how Rother Valley Optics have given us the ZYGO optical test certificate. This is completely unheard of, right? A lot of astronomical telescopes that I've seen over the years, even high quality instruments don't even come with that. Sometimes if you want a ZYGO certificate, you have to go to the manufacturer and pay for them to optically test your telescope, or pay someone to test it for you. So I do like how Rother Valley Optics done that. This is a high quality instrument in itself. It's definitely worth that money, without a doubt. £599 you can get for just the telescope alone and the case. But to be honest with you, after seeing the other attachments, you can buy them separately. Personally, if you want a complete setup with everything you need, then I would suggest you to buy the whole lot for £950 or £947. It's worth that investment because you have everything you need to get started astrophotography. Now there are a few points I need to make out which I think needs to be addressed. The one issue is there doesn't seem to be any tools. So if you're fitting the Vixen dovetails for the Guidescope and the telescope main tube, I would like to have seen at least a 6mm Allen key provided with the kit. The other thing is, with the field flattener, I would like to have seen some tools with that as well, because like you said, these Allen keys here on the original part are very small, and I've not seen, I don't know what the exact size these screws are. So, and also the tiny thumb screws inside this retainer ring as well. So if you were buying a field flattener, you would need to provide your own tools. So that's something that I think Rother Valley Optics should provide as well. So with the field flattener. So like I say, a few tools are missing in the equation, which probably will help make the kit, make it easy for everyone, because not everyone's got all the tools that can do the job. So that's another issue I need to address. The other issue is the Guidescope is quite heavy. Now, if I was going to mount this telescope on a lighter mount, like a Star Adventurer mount or a Iaptron Smart EQ mount, I would recommend to invest in a mini Guidescope. Now, bear with me, guys and girls. Rother Valley Optics are devising a mini Guidescope system for this rig. So please watch out. Don't be disheartened. They were devising a mini Guidescope. I think that will help to sort out the weight issues. Now, at the moment, as you see here, we're very, very close to 5 kilograms, probably a little bit more, which probably is the limit of the Star Adventurer and the Iaptron Smart EQ mounts. So you're really pushing the limits here. However, on this EQ5 mount, it's perfect. It can handle the weight, not a problem. So on an EQ5 mount, or maybe an EQ3 too, if you've got that kind of mount, it will fit those mounts. And again, if you've got an H EQ5 or EQ6, not a problem, right? You will have no problems with weight issues, but it will quite handle the EQ5 mount without a doddle, okay? But if you're going to mount it on smaller mounts, then the Guidescope system is good. However, I would like to see a mini Guidescope system. Will probably be okay, will probably be better for the lighter mount users. However, I haven't got Star Adventure mounts. I can't really tell you how good it perform on that. But I have tried it on the I have tried it on my smart Iaptron EQ mount, and to be honest with you, it handles it, but it's really pushing the limits on that mount. So Rother Valley Optics, please look into getting a 30mm Guidescope system, because I think that will really benefit the lighter mount users out there. Apart from that, everything else, I really can't wait to start imaging, because the image quality is absolutely astounding. All right, just by focusing on a terrestrial object on a landscape, and already I'm impressed with the optical performance. I will beg to think what it's going to be like when I start to test it out on deep sky objects, or even the moon, the planets, or something like that. But looking at the image quality, I would not underestimate this telescope, not one bit, because there's something about this telescope. It's phenomenal. And if you're paying for fine optical quality telescopes, then I would seriously consider this telescope without a doubt. Unfortunately, like always, and a lot of astronomers will get this, every amateur astronomer, as soon as they buy a telescope, or as soon as they get and receive a new telescope, I can guarantee you now, guys and girls, what happens as soon as a new telescope's in? The clouds rolling. Yeah, exactly. So unfortunately, I'm clouded out all this week, so I'm not being able to test this out for deep sky imaging, which is a real shame. And the other thing is, where I live, because I live high up at latitude, as we're drawing closer to June, we are getting very few dark nights. So I'll be lucky if I get a good hour or 2 hours of dark skies where I live. So don't worry, guys and girls, I will be testing it out and show the true capabilities of this telescope. But to what I've seen already, this is outstanding. And to be honest with you, I have a triplet refractors, I have ED refractors as well, and they're all very similar in quality, but there's something about this telescope, it sort of like steps above the mark from the rest of the equipment I have, right? There's a lot of refractors and there's a lot of telescopes that I have seen over the years, and there's always something not quite right? There's always something you have to do to make it better. Already Rother Valley Optics have designed and manufactured a telescope to suit the astrophotographer, and there are some nice touches on there, and they've really thought about this, really have thought about it. And to be honest with you, after seeing what they've got there, I can see this performing outstanding. And like with all my other refractors and other telescopes I own, there are some nice touches that even the more expensive equipment I've got also are lacking what this telescope has already got. So wish me luck when it does clear. Obviously I'm clouded out. If you like watching this video, please hit a thumbs up. Again, if you just visit my channel, please subscribe onto my channel. And again, please share this video if you like what you see. And also, please hit the bell. By hitting the bell, it'll keep you notified on the next videos coming out very, very soon. And believe me, I have got tons and tons and tons of videos that are still work in progress. So again, thanks for watching. I wish you all to stay safe, and most of all, I wish you all clear skies.